Welcome to the chapter Chemical Kinetics. See, chemical kinetics, it is a word derived from Greek language. In Greek, kinesis. Meaning of the word kinesis in Greek language, it is movement. I'll repeat it once again. Chemical kinetics, it is a word derived from Greek language. In Greek, kinesis means movement. That means under this unit, we are going to study movement of a chemical reaction or rate of a chemical reaction or velocity of a chemical reaction. Now let us see what is chemical kinetics or what is the definition of chemical kinetics. Now we can define chemical kinetics as it is the branch of chemistry which mainly deals with rate or velocity of a reaction, factors affecting rate, and also mechanism of a reaction. We'll repeat once again. Chemical kinetics, it is the branch of chemistry which mainly deals with rate of a reaction. It is also called as velocity of a reaction. It is also called as speed of a reaction. So we can study rate, velocity or speed of a reaction, factors affecting rate of a reaction, and also mechanism of a reaction. So these things can be studied under the topic chemical kinetics. Now we shall see what is the definition of rate or velocity first. See, rate or velocity of a reaction. What is this? See, we have already studied it in first year. See, rate or velocity of a reaction, it is defined as it is the change in the concentration of any one of the reactant or any one of the product with respect to unit time. So rate or velocity, it is nothing but change in the concentration of any reactant or change in the concentration of any product in unit time. We shall consider one general reaction. I will consider reactant R producing product P. Now, during the reaction, during a chemical reaction, we know that concentration means amount of the reactant, it will be high in the beginning, that is when time t equals 0, that is in the initial stage, concentration of the reactant will be very high, whereas concentration of the product, it is equal to 0 in the beginning. As time progresses or as time proceeds, concentration of the reactant goes on decreasing, whereas concentration of the product goes on increasing. That means during a reaction, there is a change in the concentration of a reactant or concentration of the product. This is what we call it as rate or velocity. So rate or velocity can be defined as change in the concentration of either reactant or product in a unit time. It is called as rate or velocity of a reaction. Let us write it. Okay, what is rate? Rate or velocity, it is nothing but change in the concentration of any reactant or any product in unit time. So we can define rate or velocity by taking reactants as well as products also. See, by taking reactant, we can define rate. How can we define rate? By taking a reactant. See, we know that during a chemical reaction, concentration of the reactant goes on decreasing, correct? Whereas concentration of the product goes on increasing. So I'll define rate of a reaction by taking a reactant. Okay. So by taking reactant, we can define rate as decrease. Rate of decrease rate of what? Rate of decrease rate of decrease in the concentration of any reactant in a unit time, that is we call it as rate. So rate of decrease in the concentration of any reactant in a unit time, it is called as what? Rate or velocity of a reaction. Similarly, by taking product also we can define rate. See, by taking product, how can we define rate? We know that during a chemical reaction, concentration of the product, it is goes on increasing. What about reactant? Concentration of the reactant goes on decreasing. So we are defining it as rate of decrease in the concentration. So while defining rate in terms of product, what we have to say is rate of increase in the concentration of any product with respect to time. Okay, that is rate of what? Rate of increase in the rate of increase in the concentration of any product in a unit time. We shall repeat it once again. So we are studying what? We are studying rate or velocity of a reaction, chemical reaction. See, rate or velocity for a given chemical reaction, it can be defined as what? Change in the concentration or change in the amount of any reactant involved in a reaction or any product involved in a reaction with respect to unit time, that is we call it as rate or velocity. Further, what I told, see, we can define rate of a reaction by taking reactant as well as by taking product also. So during a chemical reaction, we know that concentration of the reactant goes on decreasing, whereas concentration of the product goes on increasing. So by taking reactant, we define rate of a reaction as it is what? It is the rate of decrease in the concentration of any reactant in a unit time. By taking product, we can define rate as what? Rate of increase in the concentration of any product in a unit time. Now, we'll write the expression for rate by taking a reactant as well as by taking a product also. So, I'll consider the same reaction. Okay, let us consider reactant are producing a product P. Producing what? Producing a product P. Okay. Now, let R1 means concentration of the reactant. Let R1 and R2, let it be concentrations of the reactant in a time T1 and T2 seconds respectively. Okay, so let R1 and R2 represent concentration of the reactant in a time T1 and T2 respectively. Similarly, let P1 and P2. So P1 and P2, let it be concentration of the product in a time T1 and T2 respectively. So here R1 and R2 represents concentration of the reactant, whereas P1 and P2 represents concentration of the product. Now we shall write the rate of the reaction by taking reactant first. What I'll write it here? See, rate of what I wrote? Rate of disappearance of R. Why it is disappearance? Concentration of the reactant goes on decreasing. It is disappearing. So we are writing it as rate of disappearance of the reactant R. It is calculated as what you have to write? We have to write the change in concentration of the reactant with respect to time. So what I will write is, say R2, this is the concentration in a time t2 second, minus R1. What is this? Concentration of the reactant in a time t1 second. So R2 minus R1 gives what? Change in the concentration of the reactant divided by T2 minus T1. T2 minus T1. So R2 minus R1. What about the values of R2 and R1? R1 value will be high, whereas R2 value will be less, because concentration of the reactant goes on decreasing. So R2 minus R1, it is a negative quantity. So it is equal to minus delta concentration of what? Delta means change in the concentration of the reactant by T2 minus T1, that is delta T. What is this? Delta T. So delta T, it is equal to T2 minus T1. So rate of disappearance of the reactant R, it is equal to minus delta concentration of R by delta T. Similarly, we can write the expression for rate in terms of product also. Okay, we will write the expression. What I wrote, rate of appearance of the product P, it is equal to change in the concentration of product, that is P2 minus P1 divided by T2 minus T1. Now what about the values of P2 and P1? We know that in a chemical reaction, concentration of the product, it goes on increasing. So P1 value will be less, P2 value will be a higher quantity. So P2 minus P1, it is a positive term or positive quantity divided by T2 minus T1, that is delta T. So it is equal to, I will write it as plus, because P2 value, it is greater than P1. So it is delta concentration of P by what? By delta T. So rate of the reaction with respect to product P, it is equal to plus delta concentration of the product divided by delta T, whereas rate of the reaction with respect to reactant, it is given by the expression rate, it is equal to minus delta concentration of R by delta T. Remember, rate cannot be a negative quantity or velocity cannot be a negative quantity. So rate, it is always multiplied by minus 1 in order to make it a positive quantity. Hope you understood this concept. Now let us explain graphical representation of rate. What I wrote now, that is rate of the reaction with respect to reactant and rate of the reaction with respect to product, can be shown by drawing a graph also. So I will consider concentration versus time graph. Along y-axis, I will take concentration of the reactant, that is along y-axis. Time it is taken along what? Along x-axis. Time it is taken along what? X-axis. So we know that concentration of the reactant, it will be very high in the beginning. As time increases, concentration goes on decreasing. Concentration goes on what? Goes on decreasing. Okay. Now in the beginning, when time t equals 0, it will be high. As time increases, concentration goes on what? Concentration goes on decreasing. Now I will consider T1 and T2 seconds. See, this one I will take it as T1 second. What is this? This is T1 second. And this one I will take it as T2 seconds. T2 second. Now the concentration corresponding to T1 second, that is this one. This value, I'll take it as R1. So concentration of the reactant in a time T1 second, that is what? That is R1. Similarly, concentration corresponding to T2 second, that is this value. This is R2. What is this? R2. So R1 value is greater. You can see here, R1 value is greater, R2 value it is lesser. Now this difference, it is taken as what? Delta R, which is a negative quantity. What is this? Delta R. T2 minus T1. This gap, what is this? This is delta T. What is this? Delta T. Now this is the graphical representation of reaction rate in terms of what? In terms of the reactant R. Similarly, we can represent rate of a reaction by taking product also. I will take concentration of the product along y-axis, time I will take along what? Along x-axis. So concentration of the product it is taken along y-axis, time it is taken along x-axis. Now what about the concentration of the product in the beginning? In the beginning, concentration of the product it is equal to what? It is equal to 0. When time t equal to 0, concentration will be 0 in the case of product. As time increases, concentration goes on what? Goes on increasing like this. So concentration it is increasing with respect to what? With respect to time. Here also I will consider two time intervals, that is T1 second and T2 second. Okay, this one I will consider as T1 second. This is T1 second. This one I will take it as T2 second. What is this? T2. This is T1, this is T2. Now concentration corresponding to T1 second, that is this value. What is this? This value it is what? It is P1. It is P1. Similarly, concentration corresponding to T2 second, that is this one. What is this? This is P2. What is this? P2. Now this difference, that is P2, P1 difference, we can take it as what? We can take it as delta P. What is this? Delta P. Why it is plus? Because P2 value it is greater than P1. What about in the case of reactant? R2 value it is lesser than R1. So we are writing it as negative minus delta R. For a reactant, here it is plus delta concentration of the product, that is P. Now this difference, this is delta T. What is this? Delta T. So this is delta P. What is this? This is delta T. So this is the graphical representation of reaction rate in terms of what? In terms of reactant and product. We'll continue. I'll move further. Okay, next topic, average rate and instantaneous rate. Now what is average rate and what is instantaneous rate? See, average rate means this is the rate of the reaction measured for a longer time interval. What is average rate? Rate of a reaction measured over a long time interval. It is called as average rate, whereas instantaneous rate, word itself tells instant means at an instant. Okay, so instantaneous rate means rate of the reaction measured at any instant or measured for a smaller time gap that rate it is considered as what? Instantaneous rate. So if it is measured for a longer time gap, then it is called as average rate. If a rate of the reaction, if it is measured for a smaller time gap, then it is called as instantaneous rate, or then it is considered as what? Instantaneous rate. So average rate it is defined as what? Average rate means it is rate of the reaction only. Rate of the reaction measured over what? Measured over long time interval. Measured over long time interval. This is called as average rate. So average rate can be given like this. Small letter r. Small letter r means rate. Here I will write AV. AV means average. So this is average rate. It is equal to, in terms of reactant and product, it is equal to minus delta concentration of the reactant by delta T. Concentration of the reactant by reactant divided by delta T. It is also equal to plus delta concentration of P by what? By delta T. By what? By delta T. So average rate it is equal to minus delta concentration of R by delta T. It is equal to plus delta concentration of P by delta T. Now instantaneous rate means what? Definition of instantaneous rate: rate of the reaction measured what? Measured at any rate of the reaction measured at any instant of time. It is called as what? It is called as instantaneous rate. So if it is measured for a longer time interval, it is called as average rate. If it is measured for a smaller time interval, or if it is measured at a instant, then it is called as what? It is called as instantaneous rate. So instantaneous rate, it is given by the expression. Here I will write R instantaneous. Small letter r represents rate. INST means instantaneous. It is equal to minus, instead of delta we are using D. Why it is D? D represents smaller change, delta represents larger change. So average rate it is measured for a larger time gap. So we are using delta. Instantaneous rate it is measured for a smaller time gap. So we are using what? We are using D. So D means small change, delta means larger change. So R instantaneous it is equal to minus D concentration of R by dt. It is also equal to plus D concentration of the product P by what? By dt. So only change is, instead of delta we are using D. Note on the change. See delta, why it is used delta? Delta because rate it is measured for a longer time gap, so it is delta. So change will be larger. So we are using delta. For instantaneous rate, in the place of delta we are using D, small letter d, because D represents what? Smaller gap or small change. So it is dr by dt. It is equal to plus dp by dt. Hope it is clear. Okay, next one. Unit of reaction rate or unit of rate of the reaction. Let us write the formula first. See, reaction rate, it is equal to, what is rate? Change in the concentration. Change in what? Change in the concentration of any reactant or product. Change in the concentration of any reactant or product divided by time taken. Divided by what? Divided by time taken. We know that concentration of a reactant or product, it is expressed in terms of mole per liter. So unit of concentration, it is mole per liter divided by time, it is expressed in terms of seconds. So concentration, it is expressed in terms of mole per liter, time it is expressed in terms of seconds. So unit of rate is, it is mole per liter. I will take second to the numerator, so it is per second, mole per liter per second, or I can write mole liter inverse second inverse. Now this is the unit of rate. So unit of rate is mole per liter per second. Mole per liter per second, it is the unit of reaction rate. See, in the case of gaseous reaction, this one you have to remember. For a gaseous reaction, concentration, it is taken in terms of partial pressures. Concentration of a reactant or concentration of a product, it is considered in terms of what? In terms of partial pressure. Unit of pressure we know, it is atmosphere. Therefore, unit of reaction rate for a gaseous reaction, that is atmosphere per second. For a gaseous reaction, unit of rate, it is what? Atmosphere per second. So here reaction rate, that is in the case of solutions, unit of rate, it is what? Mole per liter per second. Mole per liter per second, it is the unit of reaction rate. In the case of solutions, for a gaseous reaction, unit of rate is atmosphere per second, because in a gaseous reaction, concentration, it is taken in terms of partial pressure. So partial pressure unit is atmosphere. So unit of rate becomes what? Atmosphere per second. That is, you have to replace mole per liter by what? By atmosphere. By what? By atmosphere. So till now, what and all we have studied? In the beginning, I told you about rate or velocity. Rate or velocity. What is rate? Rate, it is the change in the concentration of a reactant or a product in a unit time. It is called as rate or velocity or speed of a reaction. Now, rate or velocity of a reaction can be expressed in terms of reactant or in terms of product also. So, by taking reactant, we can define rate as, it is the rate of disappearance of a reactant in a unit time. By taking product, we can define rate as, it is the rate of appearance of the product. Rate of appearance of the product in a unit time. So, by taking reactant as well as by taking product, we can define what? We can define rate. Then after that, what I told, rate of the reaction can be expressed by taking a graph also, or by, we can explain it by taking a graph of concentration versus time. Further, I told you about instantaneous rate and average rate. Two types of rate, average rate and instantaneous rate. Average rate means rate of the reaction measured for a longer time gap. It is called as average rate. Rate of the reaction, if it is measured for a smaller time gap, then it is called as what? Instantaneous rate. For a average rate, we are using delta because time gap, it is larger. So we are using delta. For instantaneous rate, in the place of delta, we are using D, because time gap it is very small, so we are using D in the place of delta. At the end I told you about unit of rate of the reaction. Rate of a chemical reaction, it is expressed in terms of mole per liter per second. This is the unit of reaction rate, that is mole per liter per second. For a gaseous reaction, unit it is atmosphere per second. For a gaseous reaction, atmosphere per second. Or in other cases, that is mainly in the case of solutions, unit of rate is mole per liter per second. Thank you.